Thank you. I'm glad that some of you are up also after the party. But yeah, so I'm going to talk about passive DNS. It's actually a tool that has gained momentum in making a difference in tracking down criminal activity on the internet. So just a little bit about me. I work for ISC, the Internet Systems Consortium, and we have something called the Resiliency and Security Forum, where all of the security projects fall under. And passive DNS is one of them. It basically the forum itself is there for promoting real-time security-related information exchange, so that if any kind of big attacks happen, that it allows the people who need to work with each other to exchange information and work together collectively to mitigate the attack. So one of the projects that the RSF has is the Security Information Exchange. And this was something started by Paul Vixie quite a few years ago, because he thought, it's interesting. I mean, we have these people that are involved in the security community, and they have all this information that they need to exchange. Why don't we build a model like the routing community did for the internet exchanges and do a similar thing, but for security-related information? So because ISPs and SPs have been peering for quite a number of years to exchange routing information. So the SIE is built on the service provider's experience by the people who have run service providers and other large networks. And so basically what the Security Information Exchange does, it ends up getting people to connect servers onto switches, and you end up exchanging security information. So what it is, it's basically an efficient bilateral peering, a multilateral sharing within a common legal and private network. We use a scalable architecture. Currently, the Security Information Exchange has 2 locations, one in Ashburn, Virginia, the other one in Palo Alto. And how it works is that there's a number of different channels. Basically, they're VLANs. And each of these VLANs has different information, such as darknet data, spam data, also passive DNS data. So that's a particular channel on the Security Information Exchange. So just a little bit more about the channels. So oh, yeah, you can't really see the slides. Yeah. Yeah, I would prefer that light to be off as well. Thank you. So much better. Yes. So, okay. And again, feel free to ask questions also as I'm speaking. So the Security Information Exchange uses the term channel as a term for peers who are connected to a port to subscribe to the data flow. Again, so basically somebody would connect to a port, and then from that port, they would then subscribe to the different VLANs that have the different types of data, spam data, darknet data, passive DNS data, and whatever other data that the community deems is necessary to help with security-related information exchange. The one thing that's kind of interesting is that this model also allows people to exchange security information either as a community, or you can create trusted relationships with different members of this Security Information Exchange. So for example, there might be a scenario where we all trust each other and we all want to have data. But it might be a scenario where I only trust you and I trust you. And so the 3 of us would then have an agreement. We'd create our own VLAN to exchange whatever data we needed. So here's just one example. There's sinkhole data is a separate channel. So people that connect up sinkholes, if you're an SIE peer, you then end up sending that information down a VLAN, right, an SIE channel, and all the other SIE peers then get that data. So passive DNS is one of the SIE channels. And so what is passive DNS? It was something that was invented in 2004 by Florian Weimer. So he first presented this at a FIRST conference, which is a collective group of people who run different certs. And it's turned out to have many uses, specifically to help detect malware and digital crime. So inter-server DNS messages are captured by sensors and then forwarded to a collection point for analysis. And after being processed, the individual DNS records are then stored in a database. So I'm pretty sure that you guys all are familiar with how DNS works. So the way that these sensors work is that we act on the recursive servers. So we don't take a look at what the client is actually sending, but rather when the recursive server does a query to any authoritative server, the replies that we want are, or the information that we want, are the replies that are coming back from the authoritative servers. And here's just a picture that shows that. So if you've got a bunch of DNS caching resolvers, you run a passive DNS sensor. That information then gets sent through the Security Information Exchange passive DNS channel. The data gets processed. There's some filtering, deduplication that's done, and then it gets added into the DNS database. Privacy is always of concern. Varying communities or countries have different laws regarding IP addresses and what's private information. We do not store any of the source IP addresses, right? I mean, all we care about is the replies that come back from the authoritative server. And then from the sensor software that gets run, you can zero out the source IP addresses, or we just anonymize it. So depending on how you're allowed to send the data, from your country back to the U.S., the source IP address is not something that needs to be involved. Another model also that we've worked on just to allow other countries to have the capability of utilizing this technology is that we're actually building a model so that you can have your own DNS database instance either within a country, within a large corporation, and we're actually working with a bunch of European entities now to find somebody that would want to make a home here in Europe for it, because there are enough privacy issues that a lot of the information cannot be sent to the US. But within the EU, there's a number of different mandates where people can actually exchange information within each other within varying EU countries. So that's a model that we've realized that we need to work towards, and that's also true in different geographic areas, just like Asia and potentially others. So the questions that can be answered using a passive DNS database, and this is what's become really interesting to a lot of people, is where did this domain name point to in the past? What domain names are hosted by a given name server? What domain names point into a given IP network? And what subdomains exist below a certain domain name? Typically, somebody will find out that, this domain name is being used for spam. A lot of criminal activities behind here. And then you can do more research to say, who's the authoritative name server for this particular domain? And by the way, what other domains is this authoritative name server authoritative for? Because they may also be associated with malware, and they usually are. And then you can also find out the address blocks that are associated with that. This is just a user interface. If you go to dnsdb.isc.org, this is the interface that you will see. And if you see that apply there, you hit that. You'll, if any of you want to actually get the DNSDB user interface access, you could apply. You could apply for access. So the only criteria that we have is that we want to make sure that you're a trustworthy person, that you're not going to use it for anything bad, which means that we do some vetting. We just ask around to see, are you doing research, security research? Are you actually, working in the security space for your various companies? So again, passive DNS is a tool to find badness. So typically, you look up some kind of domain name, and you have a lot of criminal domain names found with a bad name server. So here, if you type in the RS at betfair.com, you get basically the records for the authoritative name server, and then you end up looking for, what other domains are associated with that particular name server. So the next slides are just a couple of searches that you can do. It was very useful for spotting the domains used in Zeus, and also fast flux, right? So which IP addresses were associated with various domains. And also to be able to find domains that are associated with spam and the IP addresses associated with certain servers. So we have a user interface where you can do some very simplistic queries. We have found that some people, do tens of thousands of queries just because DNS is so widely used in criminal activity, or it can give you clues in terms of what's associated with criminal activity. So we also have an API access available. That's reserved more for people that actually do give passive DNS feeds, or if you're somebody that's really highly involved in solving criminal activity. So just some examples. So some other uses with this passive DNS feeds that can build your DNS database. So you can look up names hosted on your networks by CIDR blocks. You can look for delisted domains and watch them move around. You can look at DNSSEC history for domains. You can look at IPv6 utilization. So we've supported IPv6 for at least over a year now. Look at resources hosted by dynamic or low-cost DNS providers. You can rebuild TLD zone files from passive DNS data. Find new names hosted in CCTLDs and track trademark names against phishing. So this here is a picture of the architecture that we currently use to build our DNS database. So we've got a bunch of passive DNS sensors. We have about 150 at this point in time. And so the data comes in to the left over there through the SIE fabric switch. It gets filtered, deduplication is done, and then it's sent off to the DNS database. So who actually gets the access? There's two types of access. There's the DNSDB user interface, and then for more sophisticated querying, there's also an API access. And the people who do get access are vetted members of the operational security community. So if you're a member of FIRST or you're a member of CERT or any other operational community, that's a given. Passive DNS contributors, and then also SIE peers. So the DNSDB user interface, I was in Delhi last week, and I was actually giving a 5-day security workshop at Apricot. And so the people in the class, we had mentioned this too, that you can get access, and 5 minutes later, boom, like everybody requested access. We don't give access to people who are just kind of looking around and want to play with it because they kind of find it interesting, but they're a vendor, and they have no responsibility really for any kind of security related things. So we do want people to actually actively be using it to have a purpose for it. And researchers are also welcome because, it turns out that researchers, as they're using or looking at this data and seeing how things change, you know, they're doing some really interesting work in tracking down some cyber criminal activities and looking at trends. So for anybody that would like to participate, you know, to add a passive DNS sensor to your DNS infrastructure, again, I want to repeat that only recursive DNS replies from authoritative servers are of interest. So we do not have any information and do not want to know, you know, what the clients are querying. All data is aggregated, so the source is obscured. Participants get access to the aggregate data for their own investigations. If you are interested in contributing to ISC's passive DNS or are interested in seeing how it would work within Europe or within Poland, send email to passivedns@isc.org. I'm going to be having a bunch of meetings over the next couple of days, actually, with different people here in Poland to see whether or not the Polish community wants to do something within passive DNS in just in Poland. And then if you do want to take a look at the DNS database and start playing with it, you know, go look at dnsdb.isc.org and apply for access. There's a line item that says, you know, give some justification. You can always say, well, you know, Merike gave a talk at PLNOG and, you know, mention what kind of security work you may be involved in. And today's talk is short, not like yesterday's. So if you have any questions, anybody have any questions about passive DNS?
So one thing that you do, if I understand correctly, is something like Google is doing for the web, but because you can't crawl the data, you are collecting the requests and responses. Is that correct?
That's correct, yes.
And do you track the frequency of requests and responses? So do you track how often something is queried for, or is it just this DNS record points to what has this information?
There is a timestamp associated with it, so yes. I mean, we don't know how often a particular person queried or you know, entity or machine, but we know how often a particular domain has been queried for.
So if there is an emerging virus that connects back to somewhere, you could see how fast that is spreading based on the queries.
Yes, exactly. And the thing is that it's real-time information, right? So it's a snapshot as of today. So we're also, because people have expressed interest in this, we also have a DNSDB export project going, so that people can actually get the data from, you know, a year ago, months back, and hourly. Any other questions?
So thank you very much for the
Thank you.
presentation.